All right, I should be live. So let me know if you can hear me. Welcome to Rollcon Office Hours. This is week 7, I believe. Wednesday, November 11th. Welcome everyone. I hope everyone is doing fine today. And let's see, let me know that I am transmitting so I know we can get started pretty shortly. So I think things should be working out now. So do let me know if you can hear me. All right, so I see that Michael is here. Hello, Michael. Thank you. See, Anna is here. Hello, Anna. Hope you're doing fine today. I see Michael. I see Anna. Who else is joining us today for office hours? I have put here on the agenda. All right, thank you, Anna, for the confirmation that you can hear me. I appreciate that. So we can get the ball rolling. Here I put the agenda, a couple of things that people have brought up. I didn't talk about on Monday, but I want to talk about them right off to start off the day. Object-oriented programming with respect to plotting, and this true mean question that someone had regarding one of the notebooks. And then with that, we can jump back right into the project that we're working on, talking about version control, a couple of things we want to still discuss with that, improvements, talk about argparse. Basically, the ultimate goal is to make a command line script that we can run whenever we are ready to run it. So I see Paulo is here. Hello, Paulo. All right. So let me know anything else to put on the agenda. And sort of our roadmap is once we wrap up this Python file to flag suspicious practices and learning about version control, then we're going to use that as a launching pad to talk about Flask. And I mentioned Flask here and there, but Flask is a Python web framework. It's a way to write web applications using Python. So I think that's going to be a good launching off point once we wrap it up. I think we should be wrap it up today, and we can start talking about Flask and all the other pieces of things we need to get a web application up and running. All right, so I see Emmanuel is here. Hello, Emmanuel. I'm going to go ahead and go into here. I'm going to open up a new notebook, new Python 3. Go ahead and rename this. I'm going to call this Office Hours, November 11, 2020. Okay. So there are one of the most popular packages for plotting in Python is called matplotlib. In matplotlib, the API, the syntax of matplotlib, is very highly influenced with MATLAB. MATLAB is a programming language that centers around numerical computations. It is popular in academia. The problem with MATLAB is it requires a license. So it's not open source, it requires a license. I used to use MATLAB when I was in university. When I was in school, I would use MATLAB. A lot of my PhD was written in MATLAB, but unfortunately it has a license and we have to pay for license fees. So it's not like Python, which is open source and free. So actually, in fact, I transitioned from MATLAB to Python. But nonetheless, the plotting API of MATLAB was influenced by a Python package called matplotlib. So import matplotlib.pyplot as plt. And we can let's play around a little bit with matplotlib to understand the syntax, and then we can talk about this object-oriented approach to plotting that matplotlib provides. Okay. So all right. So I'm going to go ahead and I'm going to import NumPy. Import NumPy as NP. I'm going to create an X linspace, create a NumPy array from, let's say, 0 to 10 of 100 spacings. And let's just create a Y that is 2x plus 1. 2x plus 1. And then what I can go ahead and do is I can say plt plot x and y, and I can do give it a marker or something like that, specify how the visualization looks like, what marker we use for the line. So very simple here, right? Just a line. And notice here was very much a imperative approach. In other words, the way we create this plot is we called upon this function here and we generated the plot. If we wanted to add labels, I can say X, and I can call upon the X label function, the Y label function. PLT title and my plot. Run that there, and I have my plot with a X and Y label and a title. So notice this was very much a working with functions. We call upon a function to generate the plot. We call upon a function to do the X label, the Y label, and the title. And this is pretty much how matplotlib works. However, there are two ways to work with matplotlib. So if I were to sketch this out, so here is matplotlib. And here we have this PyPlot API. And here we have the Object-Oriented Programming API. And this way of generating plots is very much influenced by MATLAB. MATLAB influenced and uses functions. This one here is an object-oriented programming approach to visualization. So there's two ways to generate plots in matplotlib. There is PyPlot. In fact, the way we access PyPlot is we import from matplotlib.pyplot as PLT. However, there is this alternative API, this object-oriented approach API. And let's see that today. Let's talk about a little bit about this object-oriented API. So I'm going to go ahead and say import matplotlib. And the object-oriented programming approach with visualization is kind of intuitive in the sense that you can think of, we want to create an object of a figure class. Create an object of a figure class, and then we call methods of that object, methods of that figure. Perhaps a method that adds the labels, a method that adds the actual line or the actual thing we are visualizing. So let's go ahead and explore this object-oriented approach to visualizations in matplotlib. So what I can go ahead and do is I can say something like, I have to first create my figure object. So I say fig and X, and I should think it's just PLT. Well, let me go ahead and do something a little more interesting. I'm going to go ahead and have, I'm going to do a histogram. So X mu plus sigma times some randomness. And I say number of, okay, and then I can say fig axis is equal to PLT subplots. Then what I'm going to go ahead and do is I'm going to go ahead and call on my axis object. I'm going to call hist. So I say X, the number of bins, and density equals a true. And this is going to return. Run that there. And let's see. Sorry, this axis function returns bins, n, and patches. So here n is the, if I look at the documentation, it's going to return, n should be, I think, the x-axis, so the line, an array representing the x-axis. The bins are the how the bins should represent the ranges of the bins. And here patches should be the y-axis for those bins. So all the information for us to visualize a histogram. Then what I can do next is I can add a y based upon my definition of a Gaussian curve. So here I am just generating data. So 1 divided by np square root, and I say 2 times np pi times sigma times np exponential negative 0.5 times 1 minus sigma times bins minus the average star star 2. I think that's it, but let's see my parentheses there. Okay, that makes sense. Times sigma times the exponential negative 1 times 1 over sigma times bins minus mu. I seem to have an extra set of parentheses. That's why I have, for some reason, 2 stars. Right, there's my y. And now what I can do is I can call upon the axis object and call its plot method. So I have the bins and the y, and I want a dashed line. This should be a string. Too many errors today. And then I can call set x label and here I'm going to have I can have my x, it's very simple, set y label. Here I put the probability density, and then I can say set title. So notice these are method calls, methods of an object. This object called AX that I called it, the axis. And here I put histogram. And then I can say I am ready to show my plot, PLT plot. And this doesn't show. I think the reason it's not showing is because, let's see. Something with Jupyter Notebook. I suspect this is going on, a little issue with Jupyter Notebook. Give me a sec. Because it should not have drawn this, shouldn't have called this visualization. Let me go ahead and Yeah, for some reason it should not have drawn this visualization, but I think it's because we are in the notebook environment. Things are a little tricky, a little different when we work in a notebook environment, but it should not have drawn this here. Let's see what happens if I put PLT show there instead. Okay. Go ahead and just take it from the top, run that there. Unless I have everything together. How about that? I think I might want to have everything together in one cell. Let's try that. There we go. Looks like my x-axis is probably messed up. Sorry, my histogram probably messed up somewhere in my for the y value. Just double check. Times the sigma. That seems to be correct. The exponential. Negative 0.5 times 1 over sigma times the bins minus mu. Star, star. Yeah, I think that should be all right. Okay, so notice how the way we generate this visualization is through an object-oriented approach. We create figures and axes objects, and then we call methods of those objects. And this is a different way to generate your visualizations. It's a little more verbose. Notice how it took a lot more code to write. However, it gives you more flexibility. In fact, when we talk about visualizations, what I often recommend people to do is go into the website and go to examples and take a look at the visualization you want to create. Look for one that matches what you're looking for. Maybe something like scattered and max. And look at it and adopt your approach by looking at that visualization. And some of these before, and I know I was looking at this yesterday, before it would pretty much try to promote the object-oriented approach to visualizations. But now I look at it here, it's pretty much trying to promote, this one's promoting the object-oriented approach. I believe, right here we create our axes and we call methods of those axes. And in fact, there is a different, something called Bokeh. There's a Python package called Bokeh, which is another visualization library. And this one here is meant more for interactive visualizations. Some rather impressive visualizations. And if we were to take a look at some of those, the code to create those visualizations, we see pretty much this object-oriented approach. So here's the state of Texas with some unemployment figures from about 10 years ago. And notice the object-oriented approach it's taking. So here is just formatting the data, but here is the actual creating the visualization right there. So here we create a figure object, and then with that figure object we call methods that modify that figure object. Methods that add a grid line color, set it to none, add a hover, add patches, in other words the counties, we add patches and we pass additional data. So notice it takes very much a object-oriented programming approach. You create an object, you call methods to mutate, to update the data contained or what is contained in that visualization. All right, here is another example taking a object-oriented approach. We create a figure object and then we want to create a scatter plot, so we call the scatter method of that figure, which will add scatter points. Right, here's another example. Notice we have figures. We have 4 figures, so subplots. We have a line and dots. Right, here's all the code that's formatting things. But if we were to look at what we're doing here, we create a plot object, and then we can call things like add a title, add layouts, add glyphs, create a circle object, and we add those circle objects to our plot. So we see very much an object-oriented approach. There is another Python package called Altair, another package that we can create interactive visualizations. So if I go into example gallery, and let's look at something there. Let's look at this one here. If we look at the code, notice I create a chart object, and then with that chart object, I go ahead and call mark points, so add points. We encode it, we tell it what is the X and what is the Y, what are the data, what is the X axis, what is the Y axis. We can add a selection, which here is a brush. So we add a way to select certain points here and create a new figure on the side based upon the points we are selecting. So Matplotlib is great. You can do a lot of quick and dirty visualizations with Matplotlib. A great way to explore your data. But if you want to have a more nicer presentation of your data, an interactive visualization, then you would want to use something like Bokeh and Altair. And notice it takes upon a very much object-oriented approach. So let me know if there are any questions about this. There's in fact ways to embed this into a web application. For example, here is a web application that I have where I use Bokeh to generate this visualization. So this was written using Flask, which we'll talk about next week, or perhaps as early as tomorrow, and Bokeh. So here we create a web application, we deploy it, we have this flipping the coin button here, and it's generating this visualization using Bokeh, embedded it into an HTML. So Bokeh and Flask allows you to have interactive visualization and have them embedded into a web application. Have them interacted that way. So do let me know if there are any questions. I will take a look at the chat. Okay, let me take a look at the chat here. So one query, the shared folder for Office Hours Notebooks hasn't been updated since October 27th. Would it be possible to update it soon? So the reason why that I haven't added anything there is because if you look at the Office Hours from around that time, it was mostly focused on the mini project. And so because of that, there was no notebooks to add to that folder. I don't want to add the folders of the actual mini project. I add the folders of things that I work on that are not mini project related. I think there might have been a folder or two that I created that I didn't add, so I probably should look into that and upload those there. Someone is asking, how can we access your Office Hours notebooks? Right, so if you go into, not that one. If you go into the pod, we go into video downloads. A little weird because it's called video downloads, but here is a directory called Office Hours Notebooks. And here are all the notebooks we have that I've been adding, kind of what I've just kind of do for Office Hours. Right, a couple of files as well that we work on. In fact, I'll be adding our project code into here as well. So here's a notebook about, here I put a notebook from the ML from Unit 2 about clustering. I think that helped people visualize what is happening for that clustering problem. But take a look at that. I think there's a couple other notebooks I need to throw in there, so I should get into that. All right. So let me know if there's any follow-ups. If not, we will transition. So I had a question about calculating the true mean. All right, thank you. Thank you for your comments. All right, so there was a question about calculating the true mean of a population. And we can never obtain what is the true mean of a population. We could arrive at estimates of the true mean. For example, this visualization here simulates the process of the probability, the uncertainty about what is the bias of a coin. So in other words, we have a coin that's unfair. Well, let me go back here. We can choose the fairness of a coin. In other words, what fraction of time it turns up heads. And I'm going to put 75. And then before I flip the coin, I have really no strong belief of what is the probability of the coin of turning up heads. So I say a uniform distribution. I flip a coin and I get evidence. I get evidence of how unfair the coin is. I get out of heads, so I update this probability density. As I keep on flipping this coin, after a while, I'm going to get closer and closer to the true answer. And those closer and closer to what is the probability the coin will turn up heads. But you can think of this here, this probability, this curve, as representing uncertainty. The peak here represents my best answer. And it's sort of like I'm doing an experiment. I'm arriving closer to the true answer as I get more and more data points, as I do more and more experiments. But notice how I never collapse to a single vertical line. I always have some sort of uncertainty. This uncertainty, of course, gets thinner. And if I were to do this for an infinite number of times, I will arrive at the true answer. Notice my answer is pretty close to the true probability. I'm getting closer to the true answer, and the thickness of this curve gets skinny and skinny and skinny, but never gets to zero. So the whole point here is that you can never calculate the true mean. What instead you can do is you can generate a confidence interval. In other words, what is the range, what is the most likely range for the true mean? And as you get more and more observations, that uncertainty interval gets smaller and smaller. Yeah, so I'm going to take a look at the chat here. Can you use Matplotlib and other packages for multi-dimensional representations? And the answer is yes. If you look at the Matplotlib library, there are a couple, they should have some examples of 3D visualizations. Can't see a good one. Saw one yesterday. Something like this. You could do something like that. I see something else here is, please, do you have a text we can get that contains the Bokeh, Altair, and Matplotlib to web applications? In fact, Michael, I can show you my GitHub. And let's see. Unfair Coin and Flask and Altair demo. So here is the code for the Unfair Coin. Here's the code base, right? It's on GitHub. Something like that. And here is here's one that using Altair. All right, we can have something like geothermal potential sites.herokuapp.com, right? We've deployed, well, I've deployed this. Takes a while since I use a free tier service, right? They're not going to put your project of importance. But the cool thing I like about this is that we can set things like a minimum depth and a minimum gradient. In other words, we have a set of wells in the US, abandoned wells, and we want to find certain ones that fit the criteria. We have a web form where we choose the minimum depth and the minimum gradient. And if I hit submit, what it does, it generates a map of the US with the wells that fit this prior criteria. So of course, if I want something deeper and something that is hotter, I can hit submit, and then I have the wells that fit that criteria. And there is a code there that shows you how we generate this visualization. In fact, we can probably do something like this in our web application when we work on that starting next week. And how to deploy it also to a third-party service so that you have a link you can share with everyone. So right here is, I'll put this link here that you can play around with. And last group, we can do something like this as well, where we have a weather application where where basically what it does, it takes your IP address, figures out where you live, uses a service to get the weather, and visualizes the weather for that location. Takes a while since I'm using the free tier service. Right, so apparently I'm in New Rochelle right now, and here is the weather to expect for the day. Right. Daily 24-hour forecast as well as a 10-day forecast. A nice little Wikipedia summary of where I am located. Right, so you can take a look at that. We can do something very similar for your group. Great way to tie all the different things we saw in this course as well as additional things. Working with pandas, visualizations, working with Git, and deploying our application, learning about Flask. So do let me know if there's any follow-ups so we can transition into working our project and get it into a more ready state. So do let me know if there are any questions. Okay, so let's go back to our project. So let's go data course. Where is our project? It was in prescription drug analysis. And remember, we're learning about Git as well. So we're doing changes, we're using Git. And the next thing I want to do is, let's go and look at our code. Let's be critical of it. Let's be critical of our code, right? It helps to be critical of our code. And one of the things that we are doing is, what if we want to have a different cutoff, a different z-score cutoff? I would have to go into the code and modify the value, right? If I want to have a stricter cutoff, let's say z-score of 3 and raw count of 100, I can save this and I can go back to the terminal and cd data course. And then cd, no, it's not in, it's in data course? Yes, it's in data course. And then cd into, what do I call that? I call that prescription drug analysis. And then say Python drug analysis. And run it. And then I call head on practices flagged. And there are my practices. So notice, if I have to change the z-score cutoff, I have to go in there and literally modify the code, modify the hard, right? Because I'm hard coding those values. That's annoying, right? That's annoying if I have to do that. It'd be very nice that I can specify what should be those cutoff values when I run the script. That I provide those cutoffs once I run the script. This is great because I don't want to have to modify this code, because this code is being tracked, right? If I go back to the terminal and I say git status, oh, drug data analysis has been modified. Git diff, of course it's been modified because I changed those values. So let's see how we can improve on this task here. So, right, so a quick trick. Every time in Git you make changes and you want to get back to, you want to erase those changes, right? I do git status, this file has been modified, and I do git diff, and it shows me what the difference is. what if I want to get rid of those changes? What I do is I do git checkout, and the name of the file, drug data analysis. So git checkout with the name of the file, what it does, it removes the changes of the file, the changes that have yet to been added to the staging area. Make changes, move it to the staging area, and then commit those changes. So instead of figuring out, okay, what did I change, right? I can go back here and say, oh, what did I change? I think this was 2, and I think this was with 50. No more guesswork with Git. I can do git checkout, and now if I do git status, hey, that file hasn't been changed. If I go back here and I refresh it, it's back to what I had before. Right? No more guesswork when we are working with Git. Okay. So let's go ahead and fix that problem that we have. Okay, someone is asking a question here. Is so just by uploading a file, does it get integrated to Git's tracking circle? Sorry if I missed the part. So you're saying if I upload a file to the directory, is that what you're asking? So in other words, if I were to go here and I were to say upload and put a file in this directory here, this folder, is that what you're asking? To the Git account. So let's, I can talk about this here. So one thing we should be aware of, and when I was learning this stuff, I had a very naive assumption, or I have a very naive understanding of it, is there is Git, which is a version control software, version control. But there are services that allow you to host a remote Git repository. And those services, one of the most popular ones is called GitHub. But there are other ones like GitLab, and I don't really, there's some other one. But the fact that I could only name 2 tells you that that these are the primarily most popular ones. And I mostly, so in fact, what I have here is I'm hosting my project using this third-party service. And you can add a file, and I don't know how exactly it works because I rarely add files via this button here. In fact, we can talk about remote repos. I'm kind of working up talking about remote repos, so maybe we can get those things answered. Let's see. Last thing I remember, we created these files and they were present in the data incubator system. Not sure when I got integrated to Git until now. So when you add a file into a directory that Git is tracking, those files by default aren't being tracked. In fact, remember that I created a CSV file? It's not being tracked. It's untracked. In fact, I don't want to track it. I don't want to track that file. In fact, I can go ahead and say, I can create a file called gitignore. And do new text file and rename this to gitignore. And I'm going to say ignore all files that end in .csv. This here is a wildcard. In other words, it can be anything, any characters, but it ends in a .csv. So I save that. And now with this git ignore, I do git status. There is an untracked file. So I'm going to add git ignore. Add git ignore, git commit, and call that add git ignore. So now that file is going to exclude any any .csv files are not going to be tracked. And that also is nice because it prevents me from accidentally tracking that file. All right, so let's go here. And now I'm going to add a new feature to my project, right? This idea of not hard coding those cutoffs. So it's best that I create a branch. So I'm going to do git checkout -b, and it said I'm going to call this branch command line interface support. So I created my branch. I do git status, and I see that I'm on that branch. Let's see the chat here. Is there any textbooks that has all this as content we could use to augment the practice and project-based text? I will think about that, Michael. I will think about that, and maybe I'll post that in the question forum. Any links of books. So I will get back to that. Yeah, no problem. No problem, RDX. All right, so let's go ahead and modify our file. And what I'm going to do is I'm going to import sys. Import the sys module. Then what I'm going to do is in the sys module, I'm going to say z-score cutoff is equal to sys.argv1 and raw count cutoff, I have a typo so I have to stick with it, is argv2. So what this means here is that if a user passes additional options, additional values when you run the script, the way I can access them is by this list called argv, arguments variable, in the sys library, in the sys module. So in fact, I'm going to go ahead and just do this illustrative purposes. I'm going to print out argv. I'm actually going to comment this out right here. So I'm going to import sys. I'm going to print out argv. I'm going to go back here. I'm going to run the script. Let's see what happens. Run that Python script. And notice it printed out the name of the script. So what happens is that when I run this script here, there is a variable called argv. And this variable here contains the arguments that were passed when I ran the file. And notice that since I didn't pass any arguments when I ran the file, the only thing it has is the name of the script. The only thing is the name of the script. So let's pass some additional things. Python drug analysis 1 and 2. So notice I have Python, the name of the script, followed by 2 arguments, 1 and 2. Now I hit enter, and notice what happened. Notice it printed out all the arguments that were passed when I ran the script. So the name of the file followed by 1 and 2. I can say 1 and 2 and hello, and I see drug data analysis, name of the script, 1 and hello. This works for any number of arguments. So now basically what we have here is we found a mechanism. We found a mechanism in which we can pass arguments to this file so that I no longer have to hard code these values here. Right? That's the power what we have here. So with that said, what I'm going to do is I'm going to say, okay, if the first argument is, if the 0 argument is the name of the script, I could say print running, and here I can say sys.argv 0. So this will print out the name of the script. And then what I can do is I can assign the one index to be the z-score cutoff and the next one to be the raw score cutoff. So then here I can say z-score cutoff, and here my lines are getting a little bit long, so I'm going to break it down into multiple lines. Z-score cutoff, and here raw score cutoff. Raw count cutoff, sorry, raw count cutoff. Not sure how that indentation got messed up there. And save it. So when I go back here, I can say run drug analysis and have a z-score cutoff of 3 and a raw count cutoff of 100. So running the script, right, I printed out that message. I got a name error because I probably have a typo, right? So it doesn't know what z-score cutoff is in line 72. So let's go ahead and investigate that. Line 72, z-score cutoff, and what I call this z-score cut off. And right there we go. Fix that typo. Let's run that. I got a type error. So the reason I get a type error is because the arguments that come in are strings. So let's convert them into integers. Integer. Let's run it again. Okay. And that ran. That ran my script. And now I can run it again, but you may be a very strict z-score cutoff of 4. But maybe you have to just have 50. I can run that there. And now I can type cat of my file flagged, practices flagged. And there are my practices. I have flagged those that are suspicious. All right, thank you for pointing out that error. My typo there. All right, so not too bad. I have something that that is variable. And I'm gonna go ahead and I think I'm happy with my change. So let's do get status. Let's just review the differences. That's just fixing those for aesthetic reasons. I'm just being picky. All right, so I added this here and I modified that. So I'm going to go ahead and say git add. If I want to add all the files that are being tracked, I can just do a shortcut at the -w argument and hit dot and say git commit and say add a commit that says support passing arguments via the command line. All right, I did that. And if I say get checkout master, and I can say get merge, what do I call that branch? Get, if I do get log, of course it doesn't have those changes. So I can do get branch just to figure out what my branch called. Get merge and CLI support. Okay. Now I've merged it to master and I'm ready to go. Now if I were to examine this script here, what are your criticisms? What are things that it were to, I support command line support, but maybe there's a better way to go about doing this. So anything that people would like to have as a feature or things that's a little bit tedious or maybe be great to have, what are your thoughts here? What are your thoughts here? All right, let me take a look at the chat here. What happens if we don't enter any value in the argument during runtime since we don't have the default values now? Yeah, so that's a criticism. If I were to run this script and I were to forget to have a cutoff, I get an index error, right? I have to, so I fix one problem, but I cause another one. I have the ability for the user to specify what the cutoff is, but they have to specify it. So what I could do is I can go into this script and I can have maybe some logic that says if sysargv, if the length of this is less than 3, then I can say raw count cutoff should be equal to the default. I could do something like that, right? I can do something like that. And I can hit save. I can run this here and index editor out of range. Let's see. Because I mean, just copy this and say else that. I can do something like that. So if I go here, then it works, right? I could do that. But however, what if someone doesn't provide the other one, right? Then it gets a little bit confusing. And maybe I can hard code this, but very quickly this code here gets very messy and not so elegant and hard to maintain. There's got to be a better way. In fact, there is. And that's through the args parse library. So we're going to play with that. The arg parse library. I'm going to go ahead and I'm going to save this here, but I can just say get checkout Python drug analysis. So that got rid of all those changes there. Okay, so let's learn about the arg parse library. And the arg parse library is a way where we can easily specify command line arguments. And the way it works is we're going to import arg parse. We go here. And since we're going to do a new branch, right, we can do get checkout. Let's create a new branch for this. I'm going to do get checkout -b. Call this args parse. I think that's what it's called. Does it have an S? No, it does not have an S. So let's just be consistent. Arg parse support. And I get an error. Oh, no, I didn't get an error. So let's go here and we're going to import import arg parse. And the way it works is that we create a parse object and we add what are the arguments for our script. Just close that. So we see what we do here is we first create a parse object through this arg parser. Just copy that. And I can say here, parser equals arg parse.argument parse. And then with this parse object, we're going to add arguments to it. So here we're going to add arguments. So here we're going to add an argument called echo. So what this means is that you can think of what arg parse is going to do. It's going to put all of the arguments that are passed to it into an object called parser. So let's see what we want. And let's look at the documentation here. And what we want to do is we're going to, let's see, positional and optional arguments. So we're going to go ahead and add a positional argument. We're going to call that z-score cutoff. Parser add argument, and we're going to call this z-score cutoff. And something's going on with my browser. I don't know, something fishy is going on with my browser. I think I lost something here. And if I look at it, we give the name of the file, the argument. We tell it what is the integer type. Sorry, what is the data type? Integer, along with a help message. So I say here I'm going to call this add argument z-score cutoff. Type is an integer. This is great because I don't have to worry about casting those values, changing them to integers or whatever. So I type integer, and I can say help here. And here is a little help message. The z-score cutoff for flagging practices. And then I can add another argument and call it raw count cutoff. And here is the raw count cutoff for flagging practices. And then once I have all my arguments ready, I can say args is equal to parse args, parser parse args. Okay. And then I'm going to go ahead and print args. I'm just going to print that just to see what happens. I'm going to, of course, comment this stuff out. Let's comment that out. Then run it there, and I get a nice message. Now we're out of time, and I have to go somewhere right away, so I have to pick this up tomorrow. This is a bit rushed, but we'll wrap up args parse tomorrow and see the benefits, and then talk a little bit more about Git, and then move on to working with Flask. So that said, I have to run out. A quick look at the chat here. What happens if we don't enter any value in your arguments during runtime? Yeah, we get an error message. Do we need to do checkout -b every time to add an additional Python library? The -b represents creating a new branch. So git checkout -b says we're going to create a new branch and we're going to switch to that new branch. All right, now the library is not required on our local system as it compiling from Git directly, right? Sorry if I'm getting a little confused here. We'll talk about version control, about environments when we get to our project. So that said, guys, I have to take off. We'll wrap up RxParse tomorrow. So